Hi guys, in this video we are going to look at three different types of exponential equations and how we go about solving them. The first one is the basic type where we find the variable in the exponent. In that case, you make the bases the same on both sides of the equal sign, equate the exponents and solve. Here's a worked example. We've got 5 times 2 to the power of x minus 1 is equal to 40. The first thing we try to do is get rid of the 5 by dividing both sides by 5. That leaves us with 2 to the power of x minus 1 equals 8. So remember, we need to make the bases the same on both sides. So how do we make 8 to be a base of 2? That will be 2 to the power of 3. So the next step is to equate the exponents and solve. So then x minus 1, the exponent on the left-hand side, must be equal to the exponent on the right-hand side. Solve for x. X is equal to 3 plus 1, which is equal to 4. The second type of exponential equations that we get is the common factor type. In this case, the first step is to rewrite bases in terms of prime numbers. So an example of that would be if we had 4 to the power of x plus 1. So we first write 4 in terms of prime numbers, and that will be 2 squared to the power of x plus 1. Then you get rid of the bracket by multiplying the exponents. So base 2 to the power of 2x plus 2. The next step is to split powers, and how we do this is if you had, for example, 2 to the power of 2x plus 2, we split it into 2 to the power of 2x times 2 to the power of 2. Then the third step is to take out a common factor and solve. So here's an example that I'm going to work out for you. We've got 3 to the power of x plus 2 minus 3 to the power of x is equal to 72. Okay, so the first thing we do is split our powers. 3 to the power of x times 3 to the power of 2 minus 3 to the power of x. Leave the right-hand side as 72 for now. Therefore, if you notice here, we have two terms. There's one term and there's the other term. Okay, when we have terms, we are likely to take out a common factor. So in this case, we do have a common factor, which is 3 to the power of x. Take that out, and what's left goes inside a bracket. 3 squared minus 1 is equal to 72. Therefore, 3 to the power of x times, and what's inside the bracket is 3 squared, which is 9. 9 minus 1 is 8, is equal to 72. So we get rid of the 8 by dividing both sides by 8. And that's going to give us 3 to the power x is equal to 9. Now, we try to write both sides with the same base. We've got 3 here. Can we make the right-hand side also with the base 3? Yes, 3 squared is 9. Now that my bases are the same, I can equate the exponents. That means x is equal to 2, and that's your solution. The third type of exponential equations that we get is of the quadratic type. If you look at the exponents here, you will notice that the coefficients are not the same, or one coefficient is twice the other. An example of this would be x and 2x. The other case is where you have one coefficient, the negative of the other. For example, if the one coefficient is x and the other coefficient is negative x. Okay. To solve this, we use what we call the K method. Remember, the K method is just a crutch that makes it easier for us to solve an equation or an expression. So how we do this is we say let, for example, 2 to the power of x equal k. So wherever you see 2 to the power of x in the equation, you will substitute it with k. Here's an example. I've got 3 to the power of 2x minus 4 times 3 to the power of x plus 3 equals 0. So the first step is to rewrite 3 to the power of 2x as 3 to the power of x squared minus 4 times 3 to the power of x plus 3 is equal to 0. Then we are going to let 3 to the power of x equal k. So wherever you see 3 to the power of x, you're going to substitute it with k. So therefore, 3 to the power of x squared is k squared minus 4 times 3 to the power of x is minus 4k plus 3 equals 0. Now you see it looks a lot easier to solve. You just solve a quadratic equation like we normally do. We open two brackets equals 0. K and k will go in the first terms, and 3 and 1 will be the second terms. Both of them will be minus. Therefore, k is equal to 3 or k is equal to 1. But remember, we didn't need to solve for k. We needed to solve for x. So we're going to go back and substitute k with 3 to the power of x. So then, therefore, 3 to the power of x is equal to 3, or 3 to the power of x is equal to 1. Now to solve for x, remember both bases need to be the same on both sides of the equal sign. In the first one, they are the same, so then I can say x is equal to 1. But in the second one, they are not the same, but if you look at 1, we can make 1 a base of 3. And how do we do it? 3 to the power of x is equal to 3 to the power of 0, because anything to the power of 0 is 1. So then x here will be equal to 0. And these are your solutions. Keep practicing, guys, and I'll see you in the next video.